Hello, my name is Kumasami Holovi. My theme is Experience Embedded. For Embedded Spark 2011 I have done an experiment based on embedded device creating foot map for diabetic patients. These are the contents, what I'm going to focus in the present presentation. People with diabetes are prone to having foot problems, often because of two complications of diabetes: nerve damage and poor circulation. Nerve damage causes loss of feeling in your feet, taking away your ability to feel pain and discomfort, so you may not detect an injury or irritation. Poor circulation in your feet reduces your ability to heal, making it hard for even a tiny cut to resist infection. As we age, the sense of touch decreases, because the skin's sensitivity decreases. Tissue loss occurs immediately below the skin. These changes are attributed to changes in the amount of fat below the skin, as well as decreased numbers of nerve endings. The above effect clearly tells us that it is necessary to have foot map based on sensitivity. The sensitivity test can be based on temperature or pressure. Here I have used temperature to find sensitivity of foot. Here you can see 10 locations where I am going to record temperature by placing a small object at room temperature with temperature sensor attached to it. The minimum temperature where patient is able to sense is considered, and the maximum temperature at which object will be placed is 65 degrees Celsius. These are the software and hardware resources I had utilized to complete this project.
This is the block diagram which shows my present implementation. Under power source I have used IC7805 and 9V battery of 1 ampere. Under level converter I have used Max232 for converting CMOS to TTL and TTL to CMOS. Here the role of microcontroller is to read the ADC value and wait for the response from user to record the reading. Button 1 is the response switch for the user to agree for the microcontroller to record the present reading and move on to the next. Button 2 is the switch to increase the temperature of thermistor. User has to press this button when the user is not able to recognize the object. When moving on to next reading, user has to wait for thermistor to cool down to room temperature for 2 seconds. Before user presses the response switch for the 21st time, user has to press connect button on the foot map application program, which is a graphical user interface running on VDX6318 processor based on x86 architecture. After the completion of reading, the last press of the response switch transfers the recorded value to VDX6318 processor. The foot map application program will read these values. When user presses draw foot map button on application program, it will plot the foot map based on minimum temperature sensed by foot. At the same time, user can find the result recorded under document file named as foot test result. The result can be seen on VGA monitor with the help of mouse. The VGA monitor, keyboard and mouse can be replaced by touchscreen LCD, which makes the device portable. And there is an option for touchscreen LCD. Here, you can see my initial arrangements what I have made with respect to previous block diagram. The locations where you find green circles were used as the main locations to get the minimum temperature sensed. These locations which you are able to see are of a normal patient or a normal person. The minimum room temperature was 25 degrees Celsius. So even thermistor with sensor was at room temperature. This is the foot map application program running on VDX6318 processor. You can see the result of foot map based on a normal patient's foot sensitivity to temperature being shown on WinCE7. This is the result of the normal patient's foot sensitivity to temperature, which is saved as foot test result on WinCE7. On the left-hand side you can see the application file showing the result on graphical user interface, and on the right-hand side you can see the same result of the diabetic patient's foot sensitivity to temperature, which is saved as foot test result on WinCE7. Here the room temperature was 25 degrees Celsius. and the patient is able to recognize object only above 32 degrees Celsius. So the patient has to be more careful while walking. Recordings of foot map will help doctor in medication. It will make the patient to become more sensible about his or her foot. Since the awareness of foot sensitivity increases, there will be increased care towards foot, which in turn makes foot to keep its sensitivity for a long time. Since they have given a touchscreen LCD interface, this can be made portable. Since I could not find a small touchscreen LCD at a reasonable rate at my place, I have used VGA monitor, keyboard and mouse. By this experiment, I like to say that a portable embedded device creating a foot map is essential for most of the diabetic patients and those who would have crossed an age of 50. This is even required for those who suffer from loss of foot sensitivity due to other reasons. These were the references I had gone through before developing. I like to thank all the organizers of Embedded Start 2011 for giving me an opportunity to develop this project on VDX6318 processor. I even thank for giving me a developer's experience. I had experienced embedded while developing this project. Thank you one and all.